This is a problem on the molecule, and it reads: the drawing shows the bond lengths and angles in the nitric acid HNO3 molecule, which is planar. The masses of the atoms are, for the hydrogen, 1.67 times 10 to the negative 27, for the nitrogen 23.3, and for the oxygen 26.6. Locate the center of mass of this molecule relative to the hydrogen atom. We of course expect that the center of mass is probably somewhere around here, looking at the total configuration. And then they're telling us we should choose the 0 point where the hydrogen atom is. So right there. And again, that's arbitrarily. The center of mass is still going to come out to whatever point it is. Okay. The center of mass is being calculated as follows, of course. Let's see if I have enough space here. So center of mass. Oh, first of all, I should put in here that question mark for the center of mass. That's what they're looking for. In the drawing, we can see that we have all the distances to the 5 molecules. Let's see. I'm sorry, 5 atoms. 1, 2, 3, 4, 5 atoms. So actually, I should have 5 here, and then we have the distances as well as the masses. Okay. Once again, my ultra thick friction bar, and I might as well already pull both of these down here so I have a little bit more space. And then of course it is the mass of the hydrogen times the distance of the hydrogen. And because the 0 point is chosen as where the hydrogen atom is, that of course comes out to 0. And then it's mass of the carbon times distance of the carbon plus the mass of the nitrogen times the distance of the nitrogen plus, I'm going to leave a little space here, the mass of the oxygen times the distance of the oxygen. And then, because we're only interested, no, we're not only interested, but we would have to do it in 2 dimensions, in the x and then the y. But we can see in the y, the oxygen up here is gonna cancel the oxygen down here, and that's why the center of mass comes out here just on the x-axis, and that's why we're only interested in the x-axis. And so of course we need to take the cosine of the angle times the distance. So cosine of that angle, and then it's symmetric, so the oxygen up here is going to give the same as the oxygen down here, and that's why I left the spacer. I can put a 2 in the front of that. And then of course combine all the masses, so mass of the hydrogen, mass of the carbon, mass of the nitrogen, and the masses of the oxygens. Okay, and then just a little thing, I didn't completely pay attention, so all this time that you were wondering why in the world am I talking about the carbon sitting right there, well, when I pasted the image, the O came out to be almost a C, so I took it mistakenly for a carbon. It's an oxygen. And then, even though I read the molecule earlier, nitric acid, because I'm so focused on this problem, I forgot there was nitric acid, which doesn't contain carbon. But in any case, here it is. And then you plug in numbers. I would just plug in numbers here without the 10 to the negative 10, and just say, okay, that distance here is 1.00. This distance here is 2.41. Notice that the differences here are these numbers are the differences here. So the total distance from hydrogen to nitrogen is 2.41, and then here, oh, I'm sorry. Okay. Gosh, second mistake in this one. The first one wasn't that important. This one is. This is the hydrogen distance, which is 0. This is the oxygen distance, which is the 1.00. That's the nitrogen distance, 2.41, as I explained. And then the oxygen distance here, 2.41, plus whatever this one is, with that cosine back there. And then, of course, the masses from the problems, and you plug everything in. As I said, you probably come up with something over here in meters. And for the masses, I would just leave out the 10 to the negative 27, because it just, everything in here takes 10 to the negative 27. Everything in here takes 10 to the negative 27, and it divides out anyway.